Hi everyone, welcome to the feed system design discussion. In this video, we will break down everything you need to know about designing scalable, efficient feed systems. Whether you're building social media feeds, recommendation engines, or news aggregators, a well-designed feed system is key to making sure your data gets delivered quickly, reliably, and at scale. We are going to start from the ground up, covering the basics, the components that make up a feed system, and the strategies you need to handle high traffic and large volumes of data. So, let's get started by understanding why feed systems matter and how they fit into the bigger picture of system design. Now, before we dive into feed system design specifically, let's walk through a simple yet powerful system design framework. This framework will guide us through the design process step by step. There are 4 key stages that we will follow. Step 1. Clarify requirements. This is where it all starts. Before designing any system, we need to clearly understand what problem we are solving. What are the functional and non-functional requirements? What are the use cases and how do users interact with the system? For example, when designing a feed system, you need to know what kind of content will be included in the feed, who are the users and what's their expected behavior. What are the performance requirements like latency or throughput? Clarifying these requirements upfront sets the foundation for everything that follows. Step 2. High-level design. Once we know the requirements, we can start thinking about the architecture. At this stage, we are mapping out high-level components and how they interact. They could include things like front-end and back-end interactions, message user streaming systems, load balancing and scaling strategies. Think of this step like a bird's-eye view of your system. It's a broad design, not too detailed yet, but you are figuring out the major building blocks. Step 3. Deep dive. Now, we get into the nitty-gritty details. This is where we really start to understand how each component will work. We will look at the data structures, algorithms, and the trade-offs. For example, in a feed system, we will dig into things like how will we store and serve the feed efficiently? How do we handle user preferences or rankings? What strategies will we use to answer the feed updates in real time or near real time? This is the most technical part of the design where we ensure everything works as expected and can handle edge cases. And last step, step 4, wrap up. Finally, after diving deep into the design, we need to review everything and make sure we haven't missed anything. Are the performance goals met? Do we need to scale up or optimize any part of the system? This is also where we prepare for the deployment and monitoring phase. So, that's the high-level overview of our system design process. Clarify requirements, high-level design, deep dive, and then wrap up. We will be applying this framework throughout the video as we walk through feed system design. Now that we have got the framework down, let's jump into the specifics of feed system design. Alright, now that we have laid out the framework, let's start with the first step, clarifying the requirements. This is absolutely crucial because if you don't fully understand the requirements, the design will never meet expectations. At this stage, we need to break the requirements down into 2 key areas: functional requirements and non-functional requirements. Functional requirements. In this video, we will cover core functionality of feed. So first, core functionality will be users should be able to see feeds. Second, users should be able to post or create a feed. 3. Users should be able to interact on feed, which is basically like they should be able to like, share, or comment on feeds. Now we will go next, which is non-functional requirement. For feed, we will focus on low latency. When user logs in, you would like to make sure that feed loads faster with good latency. Second, scalability, which is like we would like to make sure that we can scale the system to support 100 million plus users. Third, availability. We would like to make sure their system is available 24/7, which is like when user comes on the site on the feed, they should be able to see feed anytime, they should be able to create or interact anytime. Basically, it is possible on the system is available. And the last step, which is consistency. Now in feed, we don't really need consistency all the time, but we need consistency on particular areas. Because when you create a feed and if it doesn't display immediately, it's okay. We want to make sure that we have eventual consistency. So for today's video, we are going to focus on this core functionality and this non-functional requirements. Now, let's look into high-level design. In high-level design, we will discuss about functional requirements, and we will discuss about what components should be used and how these components communicate with each other. So let's start with our first requirement, which is users should be able to create a feed. So in this case, users basically might come from either desktop or mobile or tablet. And when they send a request to create a feed, the request will route through load balancer. So I'm adding load balancer here. And load balancer has many different types of routing algorithm. Depends on which algorithm we are using, it will route traffic to the available server. So from here, load balancer will send a request to web servers. And web servers will send a request to create feed API. Create feed API will save data into the database. And if there are any media associated with it, then we will save data into S3, especially like any images or videos, those could be stored in S3 storage. Now here is the thing, like when we are trying to save data into post database, which is just like, it can be basically, we can use either SQL Server database or additional or NoSQL database. And the structure for this will be, it will have feed ID, post HO content. Then we will have user ID and creator date. So this is our first requirement, which is create feed. How does feed API work and how does it communicate? Now there's one more thing, like what we can do here is like when we are updating data from create feed, when we are updating data from create feed API to database, we should also update their data in post cache, which is just like saving the content. Basically like it will save user ID and post ID in the data in post cache. So that way things will be taken care of immediately after we update their data into the database when we create the feed. Now let's look into our second functional requirement, which is it should be able to see feed when they log in. So when you log in into Instagram using your app, we display feed, and for that we will use feed API. This feed API will get content from post cache, and if the data is not available in post cache, then it will get data from post DB, and then it will return data to users to display it on their feed. So this is our simple flow in terms of like how should we display feed to users. Now the next and final requirement is like user should be able to interact on feed, which is like when user should be able to like on feed or they should be able to comment on feed. So in that case, we will call interaction API, which will be basically responsible to save data related to comment or likes in the database. So when user requests to or requests on commenting on any feature, any post, it will call interaction API, and interaction API will call data will save data into post DB. So this is our very high level diagram in terms of post DB. And one more thing, like the request for feed API or the request for interaction API will go directly from web servers based on the request user outstanding. So this is our very high level diagram. Now we will focus into our deep dive. In deep dive, we will focus on like non-functional requirements. How can we retrieve feed faster, or how can we scale the system availability and consistency. So our first non-functional requirement is low latency. Now let's look into our non-functional requirement. In non-functional requirement, basically we will cover like how can we deliver feed faster and how can we save data into database faster. in terms of scalability, availability, and consistency, this is what we are going to focus on now. So first, let's look into low latency. So low latency gets affected like how we save data or how we retrieve data. In this case, what happens is at high level we discussed that when user creates the feed, we will save data into database as well as we will update the post cache. We just call like push model. In this case, it works perfectly fine if there is a user who doesn't have too many friends, and writing to cache it becomes faster. And when user comes on the side and they are looking for our feed, their feed is pre-calculated and they will get the results faster. But it will create a problem when there is a celebrity who is posting something, and if we have to update millions of users of data into database or into post cache, that will be really a lot of it will create a hard key problem. It will take a lot of resources, and there might be chance that out of million friends, maybe there are many people or many users are not even active. So it is not worth it to waste our resources to update cache for those kind of users who are not active, who are not looking into feed on a regular basis. And it's unnecessary busily taking time to update data and resources to update the post cache. And in this case, what will be best is push model, which is basically like pool model. In this case, pool model will be better. The reason is like when celebrity creates a feed, instead of pushing data into post cache, we just save data into the database. And for this kind of celebrity issue, or for any user who has like more than certain number of or large amount of friends or followers, we should use this model, a pool model. So we save only data into the database, and when their friends come on the side or when their followers come on the side, that time we calculate the feed and display to the user. What benefit do we get in this case is basically like we are not wasting our resource to calculate feed and save data into post cache for unnecessary users, as well as the reading data might be slower, but the writing will be faster. So these are the benefits we get it. And I would suggest that it would be a good area to follow hybrid model instead of just push or pull model, which is like based on number of users, number of friends associated with users. We should decide, should we use push or pull model. So by doing this hybrid model, by using this hybrid model, we will be basically making sure that we don't use unnecessary resources, as well as speed becomes faster, not just in terms of writing data, but in terms of reading data, and that things will be faster. So how do we change in these cases? Like I will remove this connection here from feed API to post cache. Instead of this, I will say like feed API will get data from feed cache, and feed cache will retrieve data from post database. Now let's look into in more detail, which is like how does feed API really work. So when is a lot scene, they come up to the side and we have to display the feed. So first what we need to do is like, I will separate out the flow for feed API. What happens in this case is basically feed API will first get all their friends list from users cache or from database, which will be which will be basically responsible to get the relationship of users, followers. So it will basically return you like user IDs or follower IDs. So, and it's good to save this kind of data into GraphSQL or graph database instead of for regular database. It maintains the relationship really well. So once it gets all the followers like user ID, then we need to get users information, which is like user first name, last name, like some basic information. And it will get those information for our users from users cache. And users cache, if we don't have any data available on users cache, then it will get the data from users DB. Now, once we got user ID, user information, then we also need to get like user ID and feed ID, and based on that data, we need to get the actual feed content from feed cache. So it will get actual feed content from feed cache. And then feed cache, if there is no data available, then it will basically return data from feed database. This is overall how feed API will work, how it gets user ID and feed ID, how does it get the content. And then once it gets the content, then it will display data to the user. So this is in detail how feed API works to get the data. Now what we need to look into is and that will help us in terms of low latency or increasing speed to get and calculate data and retrieve data to the user. Because we are using cache here, we are not constantly running query on our database. And graph data, this is also really good in terms of managing the complex relationship. So this will basically help us in terms of returning results faster. So that's first criteria, low latency in terms of retrieving feed. Now we also need to care about how do we save feed or how do we interact feed faster. So basically as we discussed previously, we will consider push and pull mechanism based on number of users associated with their friends. So in this case, this was perfectly fine for pull mechanism where how it will pull the data. Now in terms of push, which happens when you are creating feed, I would suggest it would be good idea to create to push data into cache by using message queue here. So when you save data into the database, we will send all the saved data into message queue. And then from message queue, it will send all the data into post cache. And why should we use message queue? Why can't we just send directly to post cache? The reason is we have to think there is not only one user writing posts at a time. There is not only 100 users. We are thinking about big system. So there might be millions of users who is sending requests, and to consider that millions of users, we don't want to lose anything to sending post cache to push the data over there. So it would be good idea to push data into message queue, and then from message queue, it will send data to post cache. And by doing this, our cache is already ready for any users who is basically using pool model or to get data. Basically cache is already there, the calculated data is already there. They will just get the data and return the results on the site. So this is overall our concern over low latency, how it works and how can we retrieve results faster. Now let's look into scalability. We need to think about scalability almost every stages of the system. How can we scale the system? How do we make sure that web servers are scalable, feed API, interaction API, or anything? How we make sure that everything is scalable. So if we increase the traffic, certainly it should return results faster, and we should be able to support it smoothly. We should be able to scale the system smoothly. So in this case, when we look into web servers, we can add multiple web servers, which will help us in terms of horizontal scaling. Same thing for feed API or interaction API, add multiple servers for horizontal scaling. I'm just adding more servers here for your reference. For feed cache, we will be using Redis. For any type of cache, basically we will be using Redis. And Redis basically helps us to get the results faster because it has a great indexing feature. And we can scale Redis by sharding as well as by adding multiple nodes horizontally. So that is by adding multiple nodes horizontally. So that way Redis can be scaled here. And for PostDB, we can basically do similar thing, which is add replication for our replication on servers, as well as add multiple add sharding, have sharding on database. So that way you can do horizontal scaling over there. So this is in terms of scaling. One more thing, we have S3 here for our media storage. So S3 has an auto scaling feature, which is basically AWS gives really great support in scaling. You can scale it infinitely on AWS. So we don't have to do any changes here as long as we have configured auto scaling here for S3. So this is overall how do we scale the system. Now let's look into the third requirement, which is availability and then consistency. So while we were discussing about scalability, we actually indirectly took care of availability We have multiple servers. Almost every place is even for our database. We have multiple server. We have replication, and for Redis also we have multiple nodes. So at any point, if any servers goes down for any reason, there is a failure, then load balancer will route traffic to those servers which are available. Load balancer will make sure that it does not send any request to a server which is failing or which just fail. It has a mechanism of keep checking the servers which are available. So that will load balancer will make sure that system is available all the time. And now the last and final requirement, which is consistency. Consistency is basically here we need to think about consistency when we get feed, but we don't have to worry. We are okay to have eventual consistency in this case, because it's okay if you get to see feed after 1 minute of you posted or you saved it to your friends. It's not something like they're losing out on anything. It's okay to have eventual consistency. So here basically Redis has eventual consistency feature already. It posts DB. If we are using DynamoDB, then DynamoDB already has a great support of eventual consistency. So it will automatically take care of consistency in this system. So this is basically our overall deep dive for instead of our feed, which might be Instagram feed or Facebook feed. And yeah, this is the end of our non-fossil requirement discussion. Now, let's look into wrap-up. So during wrap-up, there might be questions from interview, if you had to do something differently, what will you do? Or what else do you think you are missing? Finally, whether you are designing a social media feed, a news aggregator, or a product acquisition system, the core principles remain the same: scalability, relevance, freshness, and user engagement. If you found this video helpful, don't forget to like and subscribe. Got questions, feedback, or ideas for future topics? Drop them in the comments below. I would love to hear from you. Thanks for watching, and until next time, keep building smart, scalable systems.